Okay, in 12.5, we're talking about the fundamental theorem of calculus. Now, this theorem says that if f is a continuous function on the interval AB, and capital F is the antiderivative of the function f, then the integral between a and b, lower bound a, upper bound b, of the function f of x dx is equal to f of b minus f of a. So let's get an example. If we have the integral from 1 to 2, the argument is 2x plus 3e to the x minus 4 over x dx. F, which is the antiderivative of all of this, is equal to, let's split them up because it says we can. Let's do this. 2 times the integral from 1 to 2 of x dx plus 3 times the integral from 1 to 2 of e to the x dx minus 4 times the integral from 1 to 2 of x to the negative 1 dx. Okay, that is 2 times x squared over 2 plus 3 times e to the x minus 4 times the natural log of the absolute value of x plus the constant c. Okay, simplify. That gives me x squared plus 3e to the x minus 4 times the natural log of x. And I want to evaluate this between 1 and 2. So this means I'm looking for f of 1 minus f of 2, which is approximately 23.39 for f of 1 minus 9.15, which is f of 2, which gives us 14.24. Let's do another one. This one says we have an interval between 0 and 1 of 1 over 2x plus 4 dx. Okay, this one kind of looks like a substitution problem to me, so I'm going to let u equal to 2x plus 1. Therefore, du is equal to 2 dx. Okay, now I have a 1 dx up here, but not a 2, so just like before, we're going to multiply by 2 over 2, but the numerator 2 I'm going to put up here. Okay, now I have substitution for u. This is equal to 1/2 from 0 to 1 of 1 over u du. I'm just going to take the antiderivative. I'm not going to do the 0 to 1 yet. Just take the antiderivative. I get 1/2 times the natural log of u. Go ahead and substitute it back in. I get natural log of u, which is 2x plus 4. And yes, it's going to be a plus c, but in this case, I am going to leave the plus c off so I can do the upper and lower bounds. I want to evaluate this between 0 and 1, not worrying about the c. So that is 1/2 times the natural log of when x is 1, that would give me 6, minus 1/2 times the natural log when x is 0, and that would be natural log of 4. Throw that into your calculator. That's approximately 0.20 3. Okay, I wrote this out beforehand because it takes way too long and part of my record time. It says a company manufactures X TVs per month. The monthly marginal profit in dollars is given by the equation P prime of X is equal to 165 minus 0.1X, where X is between 0 and 4,000. The company is currently manufacturing 1,500 TVs per month, but is planning to increase production. Find the change in the monthly profit if monthly production is increased to 1,600 TVs. Okay, we are looking at, remember marginal, when you see the word marginal, you have the derivative, and it goes to show that we are given the derivative. What we're looking for is the original function, 1,600 minus the original function at 1,500, which is basically the antiderivative between 1,500 and 1,600 of the function 165 minus 0.1x dx. Okay, let's take the antiderivative. You get 165x minus 0, oops, let's move that over a little bit, minus 0.2x squared, and we're going to evaluate that between 1,500 and 1,600. So that is 165 times 1,600 minus 0.2 times 1,600 squared minus, and since this is two terms, I'm going to put a bracket around it, 165 times 1,500 minus 0.2 times 1,500 squared. Okay, the bracket would indicate to you that you need to distribute a negative. Okay, that is about 36,000 for the first part minus 135,000. The difference is 1,000, which basically means, let's scooch up a little bit, says the increase or increasing the monthly production to 1,600 units will increase monthly profit by $1,000.